moving forward to the next presentation of Dr. Athos Agapiou, which I invite here to take the floor, is an assistant professor in the Department of Civil Engineering and Geoinformatics of the Cyprus University of Technology and the coordinator of the research activities of the EU Cult Laboratory, the Earth Observation Cultural Heritage Lab, and since 2022 is the deputy director of the UNESCO Chair of Digital Cultural Heritage. So he will talk a little bit more about how Earth observation is contributing to monitor and maintain cultural heritage sites. So Athos, the floor is yours. Thank you.
Okay, thank you very much. Kalimera, good morning to everyone. I am Athos Agapiou. I'm assistant professor at the Cyprus University of Technology with research interests dealing with Earth observation and remote sensing for cultural heritage. So in the next few minutes, I will try to present you some aspects dealing with the disaster risk management cycle and especially focus for cultural heritage and what has been going on in the last year in our university. But before I start, I think it is important to understand the context and how Copernicus services can be exploited to support cultural heritage. To start with, we have to recall and to remember the study released by the European Commission in 2018, 5 years ago, entitled Copernicus Services in Cultural Heritage. In that study, end users such as policymakers, researchers, and responsible authorities from Europe, including Cyprus as well, replied to targeted questions related to the potential use and how Copernicus could be fitted to address cultural heritage needs. Based on those findings, 50% of the end users reported that their requirements could be covered or partially covered by the Copernicus program or the Copernicus contributing missions. Copernicus contributing missions means high-resolution satellite data that are accessible through the Copernicus umbrella. Nevertheless, we have to keep in mind that the rest 50% reported that the end-user requirements could not be fully covered by the Copernicus program. So, on one hand, we have the space ICT component and the experts in this field focus on Earth observation and the technological evolution of the Copernicus program. And on the other hand, we have the potential end users that could benefit from space-based applications. Several reports have argued the need to increase the awareness level and to promote the potential benefits from space-based applications, and this could be done through targeted, jointly designed applications. Today, we can see an increased number of applications for cultural heritage, especially for heritage monitoring and management. This has been strongly motivated by the freely and open data policy of the European Copernicus program. At the same time, we have seen recent developments in the domain of image processing, such as big data cloud platforms and artificial intelligence image processing methods. But again, we have to admit that this technological shift remains in a scientific and theoretical sphere, at least in Cyprus, and much more is needed to have seamless applications and implementations by national bodies and responsible authorities for heritage applications. Now, concerning the disaster risk management cycle, we can see a significant overlap between potential use of satellite datasets, including Copernicus satellites, for supporting the different phases of the disaster risk management cycle, as these have been reported by the international bodies like UNESCO and ICOMOS. In a recently published study, we have reported in detail the potential contribution of Earth observation, which includes satellites and low-altitude systems, for each step of the disaster risk management cycle, related either to the preparedness, response, recovery, or mitigation actions. Of course, the already existing 6 thematic Copernicus-based services can partially cover some aspects of the disaster risk management cycle for cultural heritage. We mustn't forget some fundamental basic properties that satellite observation provides. That include, among others, systematic and diachronic observation, the wide spatial extent of recording, the free or low cost of datasets, the remote monitoring, as well as products that can be immediately used to support other needs, as the case we have seen before with the emergency. And if we want to see the wider context where we stand today, we have to recall the concept of digital earth, digital twins. Today, we often find that we have more information that we know what to do with. Today, we have more digital data as never before in the past. The hard part is not getting new data. The hard part is to take advantage of this flood of geospatial information and make it worthy and valuable to end users and, of course, to the society. For people that are not familiar with remote sensing and satellite observation for cultural heritage, it is surprising to see how well adapted space-based research is fitted to archaeological and cultural heritage science, especially in Europe. In this map, you can see only a fragment of what is going on in Europe some years ago, as well as how many different sensors, including Sentinel missions, were used for heritage applications. Looking at the scientific landscape, remote sensing technologies have been used either alone or in a synergistic way with other technologies for cultural heritage applications, while the majority of them fit under the different steps of the disaster risk management cycle. Now, very briefly, I will present you some applications related to the disaster risk management cycle carried out by team members of the Earth Observation Cultural Heritage Lab established at the Cyprus University of Technology. The focus of the lab is to develop and apply Earth observation remote sensing methods to better explore and to better understand archaeological landscapes by systematic mapping and image processing analysis. Applications are particularly extended from observations of single monuments to archaeolandscapes and their diachronic changes. For these applications, we use both optical or radar images, including Copernicus, of course, and other high-resolution satellite sensors supported by UAV campaigns and ground measurements. The research group focuses on two main research areas that I will explain in a while. The so-called site detection, and heritage monitoring. Both these topics involve several other research directions that we will see in a while. Site detection refers to the discovery of buried archaeological remains or archaeological proxies, as we prefer to mention them, using space-based applications. Shallow buried remains, which are still unknown, can be observed in satellite imageries as stretched vegetation, the so-called crop marks phenomenon. Site detection is very important for disaster risk management cycle, as it can help us to understand and map the wider context of an area. Although spatial resolution is a significant parameter to observe archaeological proxies, we can still exploit medium resolution satellite data, as those of Copernicus, to detect buried archaeological remains. In this slide, you can see a recent study focusing on the detection of the largest known Bronze Age earthworks in Europe, which was really successfully indicating unknown areas and proxies to archaeologists working in the site. New buildings and earthworks never spotted before in the past have now been mapped for the first time using open, freely distributed data. Similar studies have been carried out in other sites as well, and we are still in progress for new discoveries. Another example for the detection of Neolithic settlements using high-resolution imagery is the case you see in this slide. Targeted research needs to be done to optimize the overall approach for defining specific time windows or spectral windows that are most suitable for specific areas with archaeological interest. The synergistic use of both ESA and NASA satellite missions, like those of Landsat and Sentinel, have been applied for the archaeological site of Nea Paphos here in Cyprus, an UNESCO World Heritage Site. The integration of both sensors was reported as a Sentinel success story, providing evidence of how Copernicus data can support heritage management. Moving on from site detection to site monitoring, we can list a series of hazards and how satellite observation can be used to map and monitor different threats for heritage sites and landscapes. Here you can see an example from the analysis of satellite images aiming to map the urbanization process, the urban sprawl from the city of Paphos. To do so, we have applied supervised machine learning classification, and the results have indicated a 300% increase of urban areas in the last 30 years. Similar findings were also reported in other cities of Cyprus as well. This increase of urbanization has an impact on heritage sites and protection zones of archaeological sites. A similar study was carried out recently for the case study of Limassol. Using radar Sentinel-1 data, visualization and change detection techniques, we managed to map vertical urban expansions. Using the recent sky towers phenomenon that is taking place in the last years in Cyprus and specifically in Limassol can be mapped using Sentinel-1 time series data. Here you can see differences observed year by year starting by 2015 to 2020 for the city of Limassol. These results can be validated and cross-checked remotely using Earth observation cloud platforms, while specific indices can inform us about the time when this change took place. The results show areas that have significant change in the last 5 years. In practice, the map provides changes in the VV and the VH polarization of the Sentinel-1 sensor for the period 2015 to 2020. These changes are highlighted in the map with the yellow square you see here, while you can see the location of the Amathus site. Urban expansion can be also linked with the increase of the land surface temperature of an area. In an ongoing research project that we are involved, we are studying the fluctuations of the land surface temperature over the city of Limassol and the old center of Strovolos in Nicosia. In this project, we provide information for both areas since 2012 with approximately 2 observations per month. This multi-temporal analysis is linked with the traditional buildings and their environment, and this information is now transferred into a historical building information modeling online platform, an HBIM, that will be used by the local authorities. The satellite-based observations are connected with 3D models and ground information and will be used for energy efficiency for the traditional buildings. Moving to fires, in this slide you can see an interesting example of how Copernicus program can be used to monitor the fire intensity in a recent fire event in Orinile Larnakas in 2021. With the support of the German Aerospace Center, DLR, Sentinel-3, Sentinel-1 and Sentinel-2 were used to automatically map the fire spread and then measure the fire intensity. Using this information, along with georeference data and GIS environment, one might have almost a near real-time service for heritage management. Changes due to technological accidents, such as those of the event of Beirut, have been also carried out. The UN Cultural Agency, UNESCO, was warning about the more than 60 historic buildings that were at risk of collapse after the blast. Again, using Sentinel-1 and Sentinel-2, we were able to map in a very short time the damaged areas and provide a general overview of the destruction and affected areas. The damage proxy map produced here was aligned with those provided by the NASA area team and the German Aerospace Center team. Lastly, combining Sentinel-1 images, we can detect ground displacements, which are very helpful, especially after strong earthquakes, as you have seen before and you will see afterwards with Skevi, or if we have landslides. Here you can see an example of how we can detect small displacements after a 5.6 magnitude scale earthquake event near Paphos and important archaeological sites of the area. All these geospatial data, especially those generated from satellite sensors, can have a great importance for heritage monitoring and preservation. This idea is behind now a new funded Horizon Europe program aiming to bring together expertise from the geoinformatics domain blended with the civil engineering and archaeologists. New services only recently released, like those of the European Ground Motion Service, can be used not only to detect ground displacement, but also to support definitive element models, FEM, developed by civil engineers. In your right hand, you can see an example of how this information from space and using 3D modeling documentation techniques can be used to understand the stability of Tomb 4 at the Tombs of the Kings, an UNESCO archaeological site. So today, we have an unparalleled opportunity to turn a flood of raw data into understandable information about our society and our planet. Of course, this will not happen overnight. In conclusion, and I would like to be my message to you, which is aligned also with the scope of this workshop organized today. We need to develop a roadmap to provide solutions for the integration of satellite-based services to decision makers and institutions and increase awareness. Working together, we can help to solve many of the most important problems, including those of cultural heritage. This is really important when emergency and disasters are reported. Thank you very much.
Thank you very much indeed, Athos, for bringing all those examples of what you're doing to preserve our cultural heritage here in Cyprus. I actually will take one question, if there's any from the audience. Otherwise, I will thank you for the presentation, and I stress also on the need of, again, co-design and co-creation. So the satellite-based solutions are customizable, and they're actually really addressing actual needs when they are created based on your needs. So that's why we are here today, not only to present the possibilities offered by Copernicus and all the European infrastructure, but also to engage with you and to make sure that you are actually telling us your needs and how we can do things together. So thank you very much. From here,